Hello, algebra students, and today we're going to start working with rational exponents. A rational exponent would be some type of fraction as an exponent, or a rational number is any number that can be written as a fraction. So, we're going to start with something we know. We always want to compare new things to something we know. Now, this is brand new stuff. To be honest with you, I've never taught this to algebra students. The standards have changed, but I think you guys are smart enough to handle it. We're going to take what we know and then we're going to apply it to something new. And it's really not that bad off after all. Now, made up this table here. You've seen something like this before, right? Where we do 4 cubed and 64, and 4 squared is 16, and 4 to the first is 4. And then, of course, 4 to the 0 is 1, and for the negative first, use the reciprocal 1/4, right? But what do you suppose? Ooh, where did my pen go? Hold on. Oh, that happened again earlier. That's okay. It seems like we've got a little snafu, but it's all right. What do you suppose 4 to the 1/2 power is? Now, before you just start guessing randomly, okay, let's ask ourselves, if I took 4 to the 1/2 and I multiplied it by 4 to the 1/2, in other words, I multiply it by myself, wouldn't that be the same as 4 to the 1/2 plus 1/2, or better yet, 4 to the first power? Right? Because when the bases are the same in multiplication, I add the exponents, right? So I've got 4 to the 1/2 times itself. In other words, 4 to the first, of course, equals 4. I'm asking this question, what number multiplied by itself equals 4? Well, that would be 2 or negative 2. Hey, wait a minute, that sounds familiar, doesn't it? 2 or negative 2. What happens if I take the square root of 4? I get plus or minus 2, right? So this 4 to the 1/2 power being plus or minus 2, and we can just deal with the positive one in this chart if it screws you up, must be the same as taking the square root. So 4 to the 1/2 power is the same as the square root of 4. Yeah, they mean the same thing. If you see a 1/2 power, that's going to be the same as taking the square root of the number. Now, it's kind of cool. That also means that for the, oh, I don't want to use 4 there. Let me do 8 to the 1/3 power. That would be the same as taking the cubed root of 8. It means the same thing. It's another way to express it, okay? Because this would mean if I did 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3, that would be the same as 8 to the first, which is 8. So what number times itself again equals 8? Well, 2. 2 times 2 times 2 would equal 8. So therefore, 8 to the 1/3 must be the same as 2. Well, how can I get that? Taking the cubed root of 8. If it's to the 1/4 power, it would be the 4th root. If it was the 1/10 power, it would be the 10th root. We won't be doing any 10th roots in here. So a number raised to the 1/2 power is the same as taking the square root. A number raised to the 1/3 power is the same as taking the cubed root. All right, well, let's try this here. If I've got 100 to the 1/2 power, that's the same as taking the square root of 100. And we all know that's plus or minus 10, right? 16 to the 1/2 power, that would be the same as taking the square root of 16, which would equal plus or minus 4. All right. How do you suppose we deal with 25 to the 3/2 power? Well, it's really pretty easy. I could think about this as 25 to the 1/2 power being raised to the 3rd power. I'm taking the idea that if you do a power to a power, you multiply the exponents, and I'm actually moving backwards. I'm breaking them down into two things. I could have put the cubed here, the 3 here, but I'd rather take the square root of 25 and then cube that answer than cube 25 and try to take the square root of that number. It's going to be quite large. So I'm going to take the square root of 25, which is going to be plus or minus 5, of course, and then I have to cube it. And if I cube 5, I get 125. And if I cube negative 5, I get negative 125. So 25 to the 3/2 power is going to equal plus or minus 125. So just to recap what I did there, first take the square root of the number, then raise that answer to the 3rd power. That's for the 3/2 power. Okay, so this looks brand new and kind of strange, but really it's pretty simple. Hold on one second. Okay, check out these samples. Remember, the denominator tells me what root to take. The numerator tells me what power to use. So I can think of 49 to the 3/2 power as 49 to the 1/2 power, and then raise that to the 3rd power. Well, this means to take the square root of 49, so now I have plus or minus 7, and then I'm going to square it, and when I square it, I'm just going to go to plain old 49. Oh, excuse me, silly Mr. Lawrence. Sorry, I don't want to square it. Squaring it would just undo what I did. I want to cube it. Well, I'm going to get 7 times 7 times 7 is 343, and negative 7 times negative 7 times negative 7 is negative 343. So there's going to be 2 answers. There we go. Okay, on this one, 2/3 power. Well, I'm going to think of that as 27 to the 1/3 power, and then I'm going to square that answer. Well, the cubed root of 27, what number times itself again equals 27, should be catching on. That, of course, is 3. And then I have to cube 3. No, excuse me. I keep getting those backwards. I have to square 3, right? I already did the cube right there. 3 squared is, of course, 9. And there you go. That's pretty easy stuff. Yeah, I mean, if you're confused about how I'm doing this, well, ask yourself, what's 2 over 1 times 1/3? Well, 2/3. And I'm just working backwards from it. Okay, 16 to the 3/4 power. I could consider that as 16 to the 1/4 power. And then I will cube that answer. Well, the 4th root of 16 is 2. And then I'm going to cube that. How did I know the 4th root of 16 is 2? Because what do I multiply by itself? That to get 16. Well, 2 times 2 times 2 times 2. Yeah. And 2 cubed is 8. So, in other words, 16 to the 3/4 power equals 8. If you're not sure, you could punch in a calculator if you don't believe me. 100 to the 5/2 power would be the same as 100 to the 1/2 power. And then I'm going to raise that to the 5th power. Well, this thing here will be plus or minus 10. And then when I raise that to the 5th power, well, 10 to the 5th power is pretty easy. I believe that's 100,000. And negative 10 to the 5th power would be negative 100,000. And there you go. That is your answer. So just recapping, when you have any number and it's raised to a rational power, okay, the denominator tells you the root to take. Take this root. And I recommend doing the root first. And the numerator tells you raise that answer to this power. Okay, so we take the root first and then we raise it to the power. So if I had 4 to say the 7/2 power, well, the first thing I would do 4 to the 1/2 power. 4 to the 1/2 power is plus or minus 2 because it's the square root. And then I've got to raise it to the 7th power. See, 2 times 2 is 4. A third 2 gives me 8. A fourth 2, double it again. I'm going to get 16. I'm up 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. And one last one. 2 to the 7th be 128. So this must equal plus or minus 128. So the denominator tells me take the root, and I do that first. And the top number tells me to take the power. Now, again, I could do the power first, the numerator. It's just it'll be way easier to work with the smaller number. Okay, like 7 to the 4th is a hard number to deal with. I don't know what 7 to the 4th is. It's way bigger than 128. Okay, and then I'm going to have to take the square root of that number. All right, that's your lesson for today. Mr. Lawrence signing off. Good night, everybody.